Hi guys, welcome back to another instalment of Mr. Hutton Science. Thanks to those of you that have subscribed. We passed 100 subscribers earlier today. Keep sharing with your friends and make sure you've got notifications on so you don't miss the latest videos. The videos are designed to accompany the AQA GCSE Chemistry course, but would be appropriate for any other exam courses as well. So let's get started with today's video, which is on balancing equations. Before we start, make sure your mobile phone is turned off and out of reach. You've been to the toilet, got yourself a drink, and you've got a pen and paper to make some notes and answer some questions. So let's get started. Right, balancing equations. It is just like cooking. Okay, so if you look at this slide here, we've got some Skittles on the left hand side and different numbers of each of those Skittles. So if we added all of these groups of Skittles into a pot, put the lid on and shook it all up, how many of each Skittle would I have at the end? So hopefully you've all said exactly the same, and that is correct. At the end of this you'll still have 14 green Skittles, 18 yellow, 19 purple, 26 red and 28 orange. Okay, they might be in different positions, they could have been rearranged, but we've still got the same number of Skittles and the same number of each type of Skittle. So that is a fundamental point to balancing equations, so remember that. Right, why do we balance equations then? So there's several reasons why we balance equations. One, we've got to remember the law of conservation of mass. So the mass of our reactants is always equal to the mass of our products. So balancing an equation makes sure that that happens. It shows us the molar ratio between the different species of the reaction. So if we know how many moles of one of those species we have, we can work out the moles of another species. It allows us to calculate the mass of a product made from a certain amount of reactant. So it could be a question tells you that you've got X amount of reactant A, and it asks you to calculate how much of product B you would get. And we can do that, but only if we have a balanced equation. We can use equations to calculate the concentration of different solutions. So when you're doing titration in the quantitative part of the course, you must have a balanced equation for your neutralization reaction, and that can help you to calculate different concentrations, different volumes needed, etc. It allows you to calculate the volume of a gas produced. But overall, balancing equations is very, very important in industry. Okay, they need to know exactly how much of different reactants they need in order to get a certain number of certain mass of product. Okay, and if they don't get that right, then there's a lot of waste material, which then costs money. So it's really, really important for industry in terms of saving money. Companies can make sure they're reacting the most economical amounts of chemicals and not wasting any. Right, so when we are balancing equations, there are a few rules and guidelines that we need to stick to. Okay, so overall, you generally have reactant A and reactant B reacting to give you product A and product B. Sometimes you just have one reactant and two products. Sometimes you have two reactants and one product. Sometimes you have more than two reactants, and sometimes you have more than two products. Okay, but generally you have reactants A and B giving you product A and B. So reactants and products, they're often referred to as species. Okay, there was a bit of confusion in one of the GCSE exams last year where they referred to species in the equation, and people got confused because they thought that was a biology term. But in fact, species, that's just one of your reactants or one of your products. It's one of the things in your reaction. So get used to that term because we'll be using that as we go on. Fundamentally, there must be the same number of each type of atom on both sides of the equation. And that's really where balancing equations comes in. That's the fundamental point that you are trying to adhere to. Subscript numbers, so those are the little numbers just below the line that the rest of the formula is on. So subscript numbers in the chemical formulae of each species cannot be added, removed or changed. You cannot do anything to the subscript numbers. Okay, if you change those subscript numbers, you're actually changing what the molecule is. So you cannot touch those at all. But you can change the number of each species you've got. Okay, so remember, species are the different things in the reaction. So we can change the total number of those that we have. And you'll see how we do that later on. You can add large numbers in front of the species, okay, in order to change the number of those that we have. So the example there is 2 H2O. So that means two lots of water. The subscript numbers we've been talking about, they only influence the element before them. Okay, so if there's a subscript number after the H in H2O, then that number just means that there's 2 hydrogens. It has nothing to do with the oxygens. If they're outside of the brackets, then the subscript number means that there's for example, if it was 2, that would mean that everything inside the brackets is multiplied by 2. And we'll see an example of that a little bit later. Also remember that some elements are diatomic. So in their elemental form, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, they're all diatomic, so they go around in pairs. So quite often students will forget this, and when they're trying to balance an equation where there's one of these species involved, because they haven't made it diatomic, they find it very difficult to balance the equation. So there's a few things to remember. Apart from our rules, we do need to be able to count up the number of atoms in a formula. So we've got some examples of formulae here, and we're just going to run through how to count up the number of atoms. So that first one there, CH4, okay, we've got 1 carbon in there and 4 hydrogens. So that subscript 4 just relates to the hydrogen, not the carbon before it. The next one down, we've got C2H4. So this means we've got 2 carbons and 4 hydrogens. The next one down, we've got CaOH2, so calcium hydroxide. The OH2 is in brackets with the 2 outside, so that means everything in the brackets is multiplied by 2. So we still only have 1 calcium, but we have 2 oxygens and 2 hydrogens. The next one we've got is 2 C2H4, so that means 2 lots of C2H4. So therefore, we'll have 4 carbons and 8 hydrogens. Okay, the next one down is as hard as it's going to get, really. You've got 2 lots of calcium hydroxide. So you've got to remember that you've basically got double the amount that you had before. So we've got 2 calciums, 4 oxygens, and 4 hydrogens. Alright, we're going to run through some examples now to help you get the hang of this. Right, we'll start with example 1. So here we've got hydrogen plus oxygen to give us water. So on both sides of the equation, we've got hydrogen and oxygen. And we're just going to count up the number of each type of atom we have on either side of the equation. So the first one, hydrogen, we've got 2 because it's H2. And then oxygen, we've got 2 because it's O2. And then on the right hand side in our product, we've got 2 hydrogens and only 1 oxygen. So you can see straight away you've got an imbalance there. You've got 2 oxygens on the left, but only 1 oxygen on the right. Remember, we cannot change the subscript numbers. We can only put large numbers in front of the species to change the number of species we have. So if we want to get 2 oxygens on the right hand side, we need to change the number of water molecules or H2O molecules that we have. So we're going to put a 2 in front. Okay? So now we count up the number of atoms we have on each side again. So we've done nothing to the left hand side, so we should have 2 hydrogens and 2 oxygens still. Now then, on the right, we've changed what we've got. So we've now got 4 hydrogens and 2 oxygens. And this has helped us balance up the oxygen, but it's thrown out the hydrogen now. So on the right, we've got 4 hydrogens, but on the left, we've only got 2. So we need to do something on the left to get 4 hydrogens. And what we can do is we can only use large numbers, remember. We can't change the subscript numbers. You can't change H2 to H4, okay? But we can put a number in front of it. We're going to use the number 2. And what that has done is it's changed the number of hydrogens on the left to 4. We've done nothing to the oxygen on the left, so that's still 2. On the right hand side, it's the same as it was for the previous step. We've got 4 hydrogens and 2 oxygens. So now overall, our equation is balanced. Example 2. This time we've got magnesium plus oxygen reacts to give us magnesium oxide. Incidentally, where you see the arrow, we say reacts to form. Okay, don't say equals, because it's not equal. So we say reacts to form. So on the left we've got magnesium and oxygen, and on the right we've got magnesium and oxygen. And again, we start just by counting up the number of each type of atom we've got. So we've got 1 magnesium there, 2 oxygens, 1 magnesium and 1 oxygen. So straight away again, you can see that oxygen on the right is not in balance with the oxygen on the left. And again, you can't add in subscript numbers. Okay, so all we can do is change the number of magnesium oxides we have. So if we get 2 magnesium oxides, and then we count up how many of each type of atom we've got again, nothing's changed on the left in our reactants. We've got 1 and 2 again. But over on the right in our products, we've now got 2 magnesiums and 2 oxygens. Okay, the problem now is that our oxygen, okay, on the our magnesium on the left is only 1, whereas on the right there's 2. So what we'll do is we'll add a 2 in front of magnesium, and then we'll count them up once more. So we've now got 2 magnesiums, 2 oxygens, 2 magnesiums, 2 oxygens, and the equation is balanced. Okay, example 3. This time we've got phosphorus plus chlorine reacts to give us phosphorus chloride. So chlorine is one of our diatomic molecules, so when you're writing that out, it's Cl2, not just Cl. So we've got phosphorus chlorine, and again we're going to count up the amount of each type of atom we've got to begin with. So 1, 2, 1, 3. So this time it's our chlorine that's not balanced, and what we need to do here is we need to think carefully about the number that we're going to put in front of chlorine. Okay, we've got Cl2 on one side and Cl3 on the other. So the numbers we're looking at is we're looking for a number that is going to help us with the phosphorus chloride on the other side as well. So you've got to think what those subscript numbers will go into. So the 2 and 3, okay, they'll both go into 6. And you then think, well, 2, how many times do I have to times that to get into 6? And it's 3. So we put the 3 there. Okay, and then we add up the numbers of each type of atom again. So 1 phosphorus. We've now got 6 chlorines, because you've got 6 times 2. Okay, and 1 phosphorus in the products, and 3 chlorines in the products. But we need to change that so it matches the other side. Okay, and what we can do is we're now going to put a 2 in front of our phosphorus chloride, and again count up the number of each type of atom we've got. Nothing's changed on the left, so it should be as before, 1 and 6. But now on the right hand side, you'll notice that we've got 2 phosphorus and 6 chlorine. So the phosphorus is now the element that is not in balance. So we need to somehow get 2 phosphorus on the side of the reactants. And you guessed it, that's right. We're going to put a 2 in front of the P there. And now when we look at those, they will all balance up neatly together. So that one is now balanced as well. Okay, one more final example for you. Example 4. Okay, we've got a more difficult one here where we've got on the right hand side in our reactants, okay, boron hydroxide. So we've got the OH inside the brackets there with a 3 outside. Alright, so again we can just look at boron, oxygen and hydrogen, and to start with just add up the number of each type of atom we've got in the equation to begin with. So we have 2 borons, 4 oxygens, because we've got 3 in the first species of our reactants and then 1 in the water, 2 hydrogens, and then in our products we've got 1 boron, and now we've got oxygen and hydrogen inside the brackets with the 3 outside, so there's 3 oxygens and 3 hydrogens. So straight away we can see that it's imbalanced. Okay, what I'm going to do first is I want to balance my boron. So I've got 2 in my reactants but only 1 in my products. So to do that we're going to put a 2 in front of the boron hydroxide. Okay, and then again we add up the number of each type of atom we've got. So we've still got 2, 4 and 2 on the left. We haven't done anything to our reactants. But on the right now we've got 2 borons, and remember everything, we've got 2 lots of everything, so it's 2 lots of boron hydroxide. So everything's going to be doubled now. So we've got 6 oxygens and 6 hydrogens. Okay, and as you can see, that's completely out of balance with the reactant side now, the left hand side. So I'm going to try and balance the hydrogen. So the only way I can balance hydrogen is by changing the number of water molecules I have. Each one of those water molecules has 2 hydrogens. So in order to get 6, I need to put a 3 in front of my water. And again, we're going to add up, like we have before, the number of each type of atom we have on the left and the right. So there's 2 borons still. We've now got 6 oxygens and 6 hydrogens, 2 borons, 6 oxygens and 6 hydrogens. So that one is now balanced. This is the easiest way to do it to begin with. It helps you see how the numbers change. Once you get more confident, then you don't have to write out the numbers below, but certainly use a pencil because you will have to swap and change several of the numbers when you get more difficult equations. You'll go from side to side changing the numbers. Okay, you're going to have a go at these in a moment. We've got some questions here for you to do. There's 8 questions in total. They're relatively straightforward. There's a couple down the bottom there with brackets in, and there is one, I'll give you a clue, there is an equation in there that is already balanced where you don't have to change any of the number of the species that you've got. It's already balanced, so watch out for that one. But if you want to pause the video now and attempt those questions. Okay, so hopefully you've had a go at those questions, and I'm just going to flick up the answers now. So you can use these answers here to mark your own work. If you did find some of those difficult, then have another go. There's plenty of these question sheets around online, so do continue to practice balancing equations. It is a fundamental skill for any chemistry course. If you're having any problems with those, then do see your teacher or drop me a message. And if there's anything else that you're struggling with, then do put a comment in the message boxes below. Let me know, and I can try and arrange to do a video on that topic. Remember, if you haven't already, please subscribe to the channel, tell your friends and share it with your schoolmates, and help us to get more and more subscribers. And look out for the next Mr. Hutton science video.